Imagine you are building a network for a complex application with multiple layers, such as like web servers, business logic, and databases. And each layer needs different security rules. Normally, you would have to manage IP addresses manually for all these resources. Isn't that tedious, right? In such cases, application security groups is your best friend for simplifying network security in Azure. An AG allows you to group virtual machines based on their roles or functions, like web servers or databases, and apply network security rules to the group rather than individual VMs. This makes managing security policies feel less like a wrestling with a pile of IP addresses and more like organizing your toolbox. It's clean, scalable, and efficient. Let's discuss why AHGs are your go-to solution for securing Azure workloads. Using AHG, you simplify security management. Instead of managing individual IP addresses, you define security rules for groups, and Azure takes care of the complexity behind the scenes. AHG let you manage dynamic updates. VMs can come and go, but as long as they are part of an AHG, the security rules apply automatically. This is especially helpful in environments where VMs are spun up or decommissioned frequently. One VM can belong to multiple AHGs. Such flexibility allows you to mix and match roles. For example, a VM could be both part of a web group and a monitoring group. Using AHG, you can create fine-grained network security policies by segmenting resources based on their role. For instance, you can allow only web servers to talk to database layer on port 1433 while blocking everything else. And lastly, using AHG, you reduce maintenance overhead. Since you are not managing explicit IP addresses, you don't have to worry about updating security rules every time a VM's IP changes. That's a huge time saver. To understand how AHG works, let's picture this. You have NIC 1 and NIC 2 that belong to a web server's AHG called AHG Web. NIC 3 belongs to AHG Logic for business logic, and NIC 4 is part of AHGDB for databases. Now you can define a simple rules in your network security group to allow HTTP traffic to web servers only, or deny all database except from business logic layer. And you can prioritize the rule based on your requirement. So in this case, traffic from the internet on port 80 is allowed only to AHG Web. The default deny all inbound rule in NHGs will ensure nothing else sneaks through. A security rule blocks all traffic to AHGDB, which is your database layer, unless it comes from AHG logic on port 1433. Because rules have priorities, lower numbers mean higher priority. So rules like allow database business logic with priority 110 are processed before broader ones like deny database all with priority 120. From a security engineer perspective, let's discuss how you can make AHGs work smarter. You should plan your application security groups wisely. Before creating AHGs, map out your application architecture. Identify which roles, such as like a web, business logic, or database, need isolation and define AHGs accordingly. You should leverage service tags and AHGs. You should combine AHGs with Azure Service Tag to reduce the number of security rules. For example, use a service tag like internet for all internet-based traffic instead of defining specific IP ranges. You should stick to one virtual network per AHG. All network interfaces in an AHG must exist in the same virtual network. This will ensure clean and conflict-free rule enforcement. You should avoid overlapping rules. Associating AHGs with both subnets and NICs can create rule conflicts, so choose one strategy for simplicity. And lastly, you should test with IP Flow Verify. Use Azure's IP Flow Verify tool to check if your rules are allowing or blocking traffic as expected. This is great for troubleshooting misconfigured edges or NHs. Why should you care as a security engineer? Managing security at scale is no joke, and edges let you focus on what matters. It's like moving from manually locking every door in a skyscraper to having one master keycard system that works intelligently. With edges, you get security that is scalable, efficient, and perfectly aligned with your application architecture.